In Chapter 10, we're going to focus on vapor-liquid equilibrium. And the motivation for this is that in the follow-up course to thermodynamics, which is separations, one of the main sort of subjects that you're going to be concentrating on is distillation and how to design distillation columns. Focuses will be about designing distillation columns. And at least for the chemical engineering curriculum, distillation columns are, a good model system to focus on, because in distillation columns, it's a very complex process of, you're boiling a liquid, and then the vapor that comes off the boiling liquid, then goes up a column that has a temperature gradient that goes from hot to cold, and so this vapor then interacts with the liquid that's flowing down, and you have basically the transfer of chemical components from the liquid phase to the vapor phase and vice versa. It's a very complicated process, but you could break down this process into easily digestible chunks by using, very specific mathematical models. Okay, and so distillation columns feature mixtures of chemical species transferring between the liquid and vapor phases. Okay. All right, and as I mentioned, distillation columns are very kind of complex unit operations, but we can make an analysis of them feasible and tractable by using certain mathematical tools. And so what we're going to do in this chapter is I'm going to give you an introduction of how to apply these thermodynamic and mathematical tools for studying just mixtures, and how we could apply these tools to understand how a chemical will behave when its liquid and vapor phases are in equilibrium with one another. Behave in the vapor liquid systems.